Welcome to qnawire.
For this problem on the topic of light waves, we want to consider the situation shown in the figure with two slits S1 and S2 placed symmetrically around the central line, illuminated by monochromatic light of wavelength lambda. The slits are separated by a distance d, and the light falls on a screen sigma 1 placed at a distance d from the slits, and the slit S3 is at a central line, and S4 is a distance z from S3. We then have a second screen, sigma 2, place a further distance d away from sigma 1, and we want to find the ratio of the maximum to minimum intensity observed on screen sigma 2 if z is given the different values. So firstly, we have z equal to lambda capital D over 2 times little d, and in this case at S4 we have minimum intensity, and so the amplitude at S4 is equal to 0. At S3, we have a path difference of 0, which means we have maximum intensity occurring. And so the amplitude at S3, we'll call it A S3, is equal to 2R. And so on the sigma 2 screen, we have the ratio of intensities Imax to Imin to be 2R plus 0 all squared divided by 2R minus 0 all squared. And so the ratio of intensities is equal to 1. And so the intensities are the same. For part 2, we have Z equal to lambda times capital D over little d. And at S4, we have minimum intensity occurring, which is a dark fringe, which means the amplitude at S4 is equal to 0. And at S3, we have a path difference of 0, which means a maximum intensity occurring. And so we have the amplitude at S3 to equal to 2R. And so on the sigma 2 screen, we have the ratio of intensities Imax to the minimum intensity Imin to be 2R plus 2R all squared over 2R minus 0 all squared. And we can see that this gives us infinity. And lastly, for the third part of the problem, we have Z equal to lambda times capital D over 4 times little d. And so at S4, we have an intensity of Imax over 2. It's half the maximum intensity, which means that the amplitude AS4 is the square root of 2R. At S3, we have the intensity being a maximum, and so the amplitude at this point, S3, is equal to 2R. And so therefore the ratio of intensities Imax to Imin is equal to 2R plus the square root of 2R all squared divided by 2R minus the square root of 2R all squared. This gives a ratio of intensities to be 34.